Welcome back. This is the problem for 4.2. We have another continuous random variable x, and the PDF of this random variable was given to us. Then we have another random variable y that it's a function of the x, and the relationship between x and y is y equal 1 over radical x. In the first section, at first ask what is the expectation value of the x and what is the variance of the x. So we calculate these two parameters for random variable x. X is a continuous random variable, and we know, if I want to draw for you, if we know for a continuous random variable is if it's the minimum value and this is the maximum value. So, and this is the PDF, this is 1 over b minus a. So the expectation value of a continuous random variable is a plus b over 2. Here the a is 1, b is equal 9. So it's 1 plus 9 over 2, that is 5. The variance of the continuous random variable is equal b minus a square over 12. So 9 minus 1 square over 12 is 64 over 12, that's equal 16 over 3. So we calculate the expectation value of the x and the variance of the x. For the next part, ask what is the h of the expectation value of the x. We calculate in previous section that expectation value of the x is 5, so we just need in the formula of the h of the x put instead of the x 5, that it's 1 over radical 5. But the expectation value of h of the x is, or y, it's equal to what? Here now y is not a continuous random variable, so it cannot follow the previous formula, and we need to follow through the definition of the expectation value. We know that the expectation, so it's a start from minus infinity to plus infinity hx times fx dx. The minimum value that f of the PDF of the x is non-zero is a start from 1, and the maximum value for the non-zero value of the f of the x is 9. H of the x, the formula is 1 over radical x, or we can write x power minus half times the f of the x during this interval, follow 1 over b minus a, that here is 9 minus 1, or 1 over 8. So we have this, we need to calculate this integral. And we know that this is equal, it's equal 1 over a times 2 times x power half when x has this value. So it's 1 over 4 x, one time we can put 9, radical 9 minus radical 1 that is 3 minus 1, and it's equal to, so it's 2 over 4 or half. For part C, ask what is the expectation value of the y and what is the variance of the y. The expectation value of the y we calculated in the previous section, that it's equal half, and the variance of the y, it's equal, we need to follow the general formula for variance, that is expectation value of the y square minus the expectation value of the y square. We know that, so we need just to calculate the expectation value of the y square. For this one, we know that the expectation value of the y square, so we need again follow the formula. Is a start from 0 minus infinity to infinity, or for this problem is 1 to 9, and we have a y square times f of the x dx d of the x, because it has a function of the x, and we know y is 1 over radical x, so and f of the x in this interval is 1 over 8, so it's 1 over x times 1 over 8 d of the x. And we know if we want to calculate this integral, it's equal to ln. So this is ln of the x from 9 to 1, so it's ln 9 minus ln 1. We know that this is 0, and we have, the factor 1 over 8 here, so is ln 9 over 8. And the variance of the y is equal ln 9 over 8 minus the expectation value of the y that we calculated in the previous section is half, so the square of that is 1 over